I've been wondering how hard it could be to run a 1980s laptop off USB power. Let's find out. This is the Toshiba T1100 Plus. It's one of the world's first laptop PCs. It came out in 1986, which is over 35 years ago, and this is the original battery that came inside. I took this out right away when I noticed it was in there to make sure there wasn't any leaking or other damage going on inside. Fortunately, there wasn't. But these things are only designed to last about 5 years, these old NiCad batteries, so it is well overdue to be replaced. Now, I'm not going to be using this laptop as a portable device. It's going to be mainly sitting on a desk, much like it is now, but I do need to replace the power. I was thinking maybe USB in some form would be suitable as a replacement. So let's get this opened up and see what we have to work with inside. One nice thing about these old, a lot of devices from this era is that they just use regular Phillips head screws. It always seems like there's something catching. Hello? There we go. There we go. All right, so the layout here is actually pretty straightforward. You can see where the battery goes right here and where it connects to the board. The power jack, which is right here, says DC in 9 volts, but that's not what the computer runs off of. It actually, if you look at the battery itself, it says 4.8 volts, and that's the number that we care about. Since USB is generally 5 volts, I'm thinking we could just wire a USB power supply directly into this board and see what happens for our first attempt at getting this to work. So yeah, let's try it. Now before we go any further, I do want to mention that you can't just pick up any power supply you have lying around and use it. You do have to be providing enough current for the device that you're trying to run. So if you don't do that, you could damage the power supply itself or worse. So I'm going to find the documentation for this online, figure out what the power requirements are for this laptop, and that way we can use a power supply that's suitable for this project. I just happen to have this USB cable with one of the ends cut off from another project I was working on. Also, I've got this connector that I've clipped off of the original laptop battery. So we'll just solder these together, splice them together, plug it into the USB power adapter, and see if it works. I want to remove a good long piece of the insulation. To start, 4 wires. I'm assuming red and black are power and ground, and white and green are data. So what you might have noticed is there's actually 2 red wires and 2 black wires on the battery connector. I'm not sure why that's the case, but what I'm going to do is I'm going to test for continuity on the battery itself. So I'm hoping, to simplify things, that these are, okay, we're going to test black to black here, red to red. Okay, all right. Yeah, so I got continuity in both cases. Yeah, so I could just basically treat this as a single red and single black wire. I don't know why it's set up that way, but that's the way it is. All right, I've got it plugged into the power outlet. I'm going to turn it on. I don't have the screen connected, so what we're going to do is we're going to listen for the beep that happens after the memory test, and we should also be able to hear it accessing the floppy drive as well. Hopefully that all works without the screen connected, but I expect it will. All right, this is a little bit scary. I'm going to turn on the power, and hopefully no smoke comes out. Oh, I think I see a light. Hold on, I'm going to skip the memory test. All right, that's a good sign. It's running. That's great. You know, I think I did see an LED flashing over here that I didn't expect. All right, so I've got the top of the case where the LEDs are labeled. You can see right here, the one that I wasn't expecting to see is the low battery light. When I turned it on and the floppy drive was accessed, the low battery indicator turned on as well. And let me turn it on again and you can watch. So I did a little bit of research and I think I understand now why we're getting the low battery indicator. If you look at the USB specification, it says 5 volts plus or minus 5% under load. When we access the floppy drive, that's actually causing a voltage dip. Now, 5 volts minus 5% is 4.75, which is just barely less than the 4.8 volts listed on the battery. The laptop sees that as the battery needing to be recharged, and that's, a little bit misleading because we don't even have a battery. So I feel like there's a better way to do this, and that's what we're going to try next. I'm going to briefly connect the laptop to this DC power supply to see how voltage affects the low battery indicator. So yeah, I'm going to turn on the supply. Let's see, it's set at 5 volts. I'm going to turn on the laptop. There we go. I'm going to very slowly dial this down. 4.9 volts, 4.8, 4.7. Okay, you can see the light turns on at 4.7. What we need to do is control the voltage, and one way to do that is with something called a USB buck boost converter. It's got USB inputs, and just like the bench power supply, it's got a knob that you can turn to fine-tune the output voltage. One of the features of this particular unit is that it has quick charge capability, which means if you have a power adapter that's compatible, it'll deliver more power to your device. Okay, we've got it plugged in now. FC stands for fast charge, so the quick charge feature is working. It's set to 4.87 volts now. We're going to just turn this knob until we get up close to 5 volts. There we go. And then on the end here, we've got these spring-loaded contacts so that the connector can plug right in there for the laptop itself. So this old connector and these wires are in pretty rough shape, so I picked up some new parts and some wire from another project and a crimping tool, and we're going to build a new one. So we want to start with the wire here. We've got some multi-conductor wire that we can just cut a piece off. The ones we care about are the red and the black, so we're just going to separate that. And this is stranded wire, so we're just going to give it a little bit of a twist there. Then what you want to do is break off one of these sockets. Just wiggle that back and forth. Okay. Insert the wire into the socket. Then we're going to take the crimping tool and line that up the best we can. Okay. And insert the socket into the housing. Push it in until you hear a click. And if you did a good job, it should be nice and secure. Here it is completed. I've twisted both pairs together and tinned the ends, and now we can just plug these into the spring-loaded contacts here and finally test it out. All right, we'll just plug this into the board and turn on the power. On, skip the memory test. Hey, it works, and it looked like it went down to 5 volts, and that's it, so we're good. This is going to work great to power the machine, and it also fits perfectly in the battery compartment where the old battery was, so that worked out conveniently. The question is, how are we going to wire this with a USB port in the back without drilling holes or something similar? And I think I found a non-destructive solution for that. So here in the back of the computer is a plate covering an expansion bay. And I think what we're going to find when we open this up is there's going to be a space where we can feed a cable through and back around to the power supply. Okay, I think that'll work. Okay, so this is a very tight fit, especially with all that extra cable. It took me a while to get it organized, but I think it looks nice and tidy, and I think we're ready to close this up, put the top back on, and test the screen and everything else. Let's do it. Now that we've got the case back together, let's plug in the power and make sure that the entire laptop works, including the screen. That is pretty amazing. I'm actually surprised at how good the screen looks after all these years. There's no floppy disk in the drive, which is why we're getting this message, but there's one thing I want to do before we actually test this machine with some software. I don't like how this expansion bay is open like this, but obviously we can't put the original cover back on because, well, the cable's in the way. So the entire purpose of using a cable like this is so that we can design a new cover with a hole in it so that it can be mounted correctly. So let's go over to the computer and I can show you what I mean. What I usually do is I start building the basic shape of the thing that I want to recreate, and then I go back and get the precise measurements I need to make it more accurate. Even if you don't have a 3D printer, the part's pretty small and you could probably send the file off to a 3D printing service and have them print it for you pretty cheaply. You could drill a hole in the original metal cover if you had to, but it's nice to avoid that if possible. I'm really pleased with how this turned out. It fits perfectly. I'm going to test an old text adventure game called Space Quest. When I was a kid, my dad had this exact model of laptop, and he would bring it home from work, and I would play games like this all the time. The screen, I mean, it's obviously not meant for gaming with only 2 colors, but I was just thrilled to be able to play games at all. And this is exactly what it looked like. It's doing exactly what it's supposed to. Well, that was a really enjoyable project to work on, and it wasn't too difficult. It did take a couple of attempts. Wiring the power adapter directly into the laptop didn't work, but once we got the boost converter in there, it worked great. So there was no soldering involved, it was completely non-destructive, and I think it wasn't that big of a challenge. So I was wondering how hard it could be to power this laptop off of USB, and because of those reasons, I think it was easy. Please let me know what you think in the comments below. Thanks for watching, and we'll see you next time.